Hey guys, it's Rishi once again. Welcome to our third and final section of functions. So in the first video, you learned how to write functions and to pass arguments so that your functions have access to the information that they need in order to do their work. You learned how to use positional and keyword arguments, and you saw functions that display outputs and functions that work with lists, as well as if statements and while loops. So now in today's video, we're going to be focusing on lists as well as modules. And that's where you can store your functions in separate files. So your program files will be simpler and easier to understand. Before finally learning how to style your functions so your programs will continue to be well structured and as easy as possible for you and others to read. So don't forget that functions allow you to write code once and then reuse that code as many times as you want. So with that, let's jump into it. Wonderful. So you'll often find that it's useful to pass a list to a function. Now, whether it's a list of names, numbers, or more complex objects such as dictionaries, when you pass a list to a function, the function gets direct access to that content of that specific list. So let's use functions to make working with lists more efficient. So I'm going to go ahead and go through an example of a list of users. And this is where we are going to send a list of names to a function called greetUsers, which greets each person in the list individually. So the first thing I'm going to do is go ahead and define my greetUsers. I'm going to take one parameter, which is names. I'm then going to go ahead and write out my docstring and print out a simple message, before going ahead and writing out our for loop and then a message before printing that message. So what have I done? I've gone ahead and defined greetUsers. So it expects a list of names, which then it stores in the parameter names. The function then loops through the list that it receives and prints a greeting to each user. So now all I need to do is go ahead and provide a list and then call my function. So again, outside of our function, let's go ahead and define our list, Liam and Lyric. And then I'm going to go ahead and call my function, greetUsers usernames. So now let's go ahead and print this out. And you can now see this is the output that we wanted. Every user now sees a personalized greeting, and you can call the function anytime you want to greet a specific set of users. So we've got hello Lyric, Liam, and Rishi. But let's suppose that we want to go ahead and modify the list in a function. So when you pass a list to a function, the function can modify it, and any changes made to that list are permanent, allowing you to work efficiently even when you're dealing with large amounts of data. So let's consider a company that creates 3D printed models. And now designs that need to be printed are stored in a list. And after being printed, they're moved to a separate list. And so let's go through this example. What I'm going to do first is go ahead and start with some designs that need to be printed. So I'll start off by writing out my list. So I've now gone ahead and written out my list unprinted designs, and I've put 3 values in that list. And then I've gone ahead and created a completed models list, which is now empty. And let's go ahead and simulate printing each design until none are left, before then moving each design to the completed models after printing it. So this is where we're going to bring in our while loop and say while unprinted designs, get our current design and make that equal to our unprinted designs dot pop. So again, with this function, I'm assigning the unprinted designs dot pop to a new variable, which is current design. And the reason I'm doing this is merely to ensure that I am removing the last element from my unprinted designs model and then putting it into my completed models list. And then we can go ahead and simply print out our printing model before going ahead and calling our completed underscore models and appending our current design to it. And now that is all done, we can simply go ahead and display all of the completed models. And there we are. So what have we done here? Our program starts with a list of designs that need to be printed and an empty list called completed models that each design will be moved to after it has been printed. And now, as long as these designs remain in unprinted designs, the while loop will then simulate printing each design by removing a design from the end of the list. And that is again through our pop method. And once removed, it will store this in current design. It then goes ahead and appends our current design to our completed model before running our for loop, which will then go ahead and print the following models that have been added to our completed models list. So let's go ahead and print this out. And we can now see we have printing our racing cars, robots, and the iPhone case, followed by the following models have been printed. And now we know these are moved to our completed models list. As you can see, we've gone ahead and printed this out in line 159. So now we can reorganize this code by writing two functions, each of which that does one specific job. Now, most of the code won't change. We're just making it more efficient. So we'll have two functions. The first, which will handle printing the designs, and the second, which will summarize the prints that have been made. So let's go ahead and define our function here. And we'll go ahead and include two parameters, one which is our unprinted designs and one which is our completed models. And now that is done, let's go ahead and cut our list out, and then we can paste this at the bottom of our program. So now that is done, let's go ahead and create our second function, which is around our completed modules. And that again, we'll put define show completed just above our following models that have been printed. So now that we've added our print models function as well as our completed models function, let's go ahead and print these out. So we'll have print models, and we'll take our unprinted designs and our completed designs. And then go ahead and call our show completed models function, where we will have our completed models. So now that is all done, let's go ahead and print this out. And we can now see we're getting the same output. And at first, we've defined the function print models. It's taken two parameters that need to be printed and a list of completed models. And given these two lists, the function simulates printing each design by emptying the list of unprinted designs and then filling up the list of completed designs, which is within our second function. And now given this list, show completed models displays the name of each model that has been printed. And the code that does most of the work has been moved to two separate functions. And this just simply makes the main part of the program easier to understand. So now this program is easier to extend and maintain than the version without functions. And if we need to print more designs later on, we can simply go ahead and call print models again. And if we realize the printing code needs to be modified, we can change the code once and our changes will take place everywhere the function is called. So this example also demonstrates the idea that every function should have one specific job. The first function prints each design, and the second displays our completed models. And this is more beneficial than using one function to do both jobs. So remember, I'm not only teaching you how to code, but also to structure your code in a way that is easier for you to understand and as well for other programmers. So try to split the code into two functions or more functions depending on the different tasks that you will be carrying out. And that brings me to the next point, which is preventing a function from modifying a list. So sometimes you'll want to prevent a function from modifying a list. For example, let's say that you start with a list of unprinted designs and write a function to move them to a list of completed models. So as in the previous example, you may decide that even though you've printed all of the designs, you want to keep the original list of the unprinted designs for your records. But because you moved all of the design names out of unprinted designs, the list is now empty. And the empty list is the only version you have. So the original is gone. So in this case, you can address this issue by passing the function a copy of the list, not the original. So any changes the function makes to the list will affect only the copy, leaving the original list intact. So let's see exactly how we can send a copy of a list to a function. So again, my syntax would be my function name followed by my list name. And again, the slice notation makes a copy of the list to send to the function. So if we didn't want to empty the list of unprinted designs, we could call the print models like this. And firstly, we'd start off by calling our print models, our unprinted designs, with our slice notation, followed by our completed models. So the function print models can do its work because it still receives the names of the unprinted designs. But this time it uses a copy of our unprinted designs list, not the actual unprinted design. So the list completed models then fills up the names of the printed models like it did before, but the original list of unprinted designs will be unaffected by the function. So even though we can preserve the contents of a list by passing a copy of it to our functions, you should always pass the original list to functions unless you have a specific reason to pass a copy. And that's mainly because it's more efficient for a function to work with an existing list to avoid using the time and memory needed to make a separate copy, especially when you're working with large lists. But hey, that brings us to the end of our first section of today's video. Let's go ahead and pause the video as I've got 3 programs that I would like you to jump into. And then feel free to press play where we will then go through the solutions. Welcome back. Let's now jump into those solutions. So let's go into our chapter 7 solutions and let's go through those 3 programs. So the first program asks you to make a list of magicians' names and then pass the list to a function called show magicians, which then prints the name of each magician in the list. And now we've done something like this in our previous chapter, so I hope this wasn't challenging for you. So again, we're going to start off by defining our show underscore magicians, and we'll take one parameter, which is magicians. We'll then go ahead and add our doc string, and we'll write a short message. Before going ahead and running our for loop, so for magician in magicians, and printing that out. And then we'll go ahead and create a list of magicians. Remember, we're using the square brackets for a list, and we'll put in our arguments. And then we'll finish off by calling our function show magicians, magicians. And let's go ahead and run this. Oh, and we have an error. So the attribute error is what we get, and it states that list object has no attribute title. And the reason for that is in line 153, I've got magicians.title when it should be magician. And you can now see that our magician variable in 152 is not being accessed. So let's change that to magician. And as you can see, it's now being accessed as the color has changed. And let's go ahead and run this. And there we are. You can now see we've got Harry Houdini, David Blaine, and Teller. So the reason why I had purposely put that error was mainly to showcase what types of errors you can still get and how to rectify those errors. I know most of you had already seen that this was not being accessed, but it was always good to show you the errors that you can get and how to solve them. Wonderful. Let's now move into the second program. And that is where we need to start with a copy of our program from exercise 7.9 and then write a function called make great that modifies the list of magicians and adds the phrase the great to each magician's name before then calling the magician to see that the list has been modified. So again, I'm going to go ahead and copy out this program here and paste it below. And this time, go ahead and create another function, but this time call this make great before putting magicians as my parameter. And then again, adding a doc string. And then we'll go ahead and assign an empty list to our great magicians. So now that is done, we need to go ahead and write out our while loop. So while magicians, and then go ahead and use our pop method to pop each magician from our magicians list before calling our great magician, which equals to magician plus the great. And then going ahead and appending our great magician to our great magicians. And then let's go ahead and move to writing our for loop. And that again is adding the great magician back into magicians before returning magicians. And as you can see below, we have our 3 magicians in our list and then our function call. So let's go ahead and print this out. And we'll go ahead and print a new line firstly to separate this, and then call our make great and magicians, and then our show magicians. And now that is done, let's go ahead and print out our code. Wonderful. And we can now see we've got our 3 magicians. And then finally, in our new list, we have our 3 magicians, but this time we've got the great added at the end of this. Wonderful. And then let's go over to our final program here. And that is where we need to start with our work from our previous exercise and then call the function make great with a copy of the list of magicians' names. And again, because the original list will be unchanged, we then need to return the new list to store it in a separate list and then call show magicians just to see our original list and our list with the great added to each magician's name. So this time I'm going to simply go ahead and add in my print statement, and I'll call this great magicians before calling my great magicians and make great with my magicians and my list being copied. And then I'll call show magicians and then enter in great magicians, which is my list. And then we'll go ahead and print our original list. We'll do a /n original list before calling our function once more and then putting our magicians in there. So before we go ahead and run this, let's go up and comment out these 3 lines to avoid any unexpected outputs. And let's go ahead and run our program. And wonderful, we can now see our original magicians as well as our great magicians. And those are being modified with the great being added to them. Amazing. And that now brings us to the end of our first section. So let's jump back into functions where we will be passing an arbitrary number of arguments. So what is an arbitrary number of arguments? So sometimes you won't know ahead of time how many arguments a function needs to accept. So fortunately, Python allows a function to collect an arbitrary number of arguments from the calling statement. So let's consider a function now that builds a pizza, and it needs to accept a number of toppings, but we can't know ahead of time how many toppings a person will want. So we're going to take one parameter, which is asterisk toppings, but this parameter collects as many arguments as the calling line provides. So let's go ahead and define our make pizza, and we're going to take one parameter here, and that is asterisk toppings. We'll then put in our docstring, and then we'll go ahead and print out our toppings before going ahead and making 2 calls to our function. So let's go ahead and run this. And there we are. We can now see we've got pepperoni, mushrooms, green peppers, and extra cheese. So the asterisk here in this parameter name tells Python to make an empty tuple called toppings and pack whatever values it receives into this tuple. And so the print statement in the function body produces an output showing that Python can handle a function call with 1 value and a call with 3 values. And it treats the different calls similarly. So note that Python packs the argument into a tuple, even if the function receives only 1 value. And before I move on, I'll go ahead and simply comment out my code to avoid any unexpected errors. So now let's take this one step further. We can now simply replace this print statement with a loop that runs through the list of toppings and describes the pizza being ordered. So now this function will respond appropriately, whether it receives one value or three values. And let's see what we get as an output. And there we are. We can now see making a pizza with the following toppings, and we've got pepperoni, and then our second function call with our three toppings. So again, this syntax works no matter how many arguments the function receives. But if you want a function to accept several different kinds of arguments, then the parameter that accepts an arbitrary number of arguments must be placed last in the function definition. So as we covered the positional and keyword arguments previously, they will have to go first and then collect any remaining arguments in the final parameter. So this is now our positional and arbitrary arguments. So if the function needs to take in a size for the pizza, that parameter must come before the parameter asterisk toppings. So now let's go ahead and copy out this program. And I'll also comment it out so we don't get two different results. And this time I'll go ahead and add in the size, which can be 16-inch and a 12-inch size. And I'm going to modify my print statement as well. And this time I'm going to make it say, making a size inch pizza with the following toppings. And I'll also go ahead and add my size as my parameter. And then let's go ahead and print this out. And there we are. We can now see we've modified our print statement, and Python now stores the first value it receives in the parameter as size. And all the other values that come after are stored in the tuple toppings. So the function calls include an argument for the size first, followed by as many toppings as needed. And now each pizza has a size and a number of toppings, and each piece of information is printed in the proper place, showing the size first and the toppings after. And so let's now move over to using arbitrary keyword arguments. So now we've seen how we can accept a number of arguments, but you won't know ahead of the time of what kind of information will be passed to the function. So in this case, you can write functions that accept as many key value pairs as the calling statement provides. So one example will be building user profiles. And you know that you'll get information about a user, but you're not sure what kind of information you'll receive. So let's now take a look at an example that I've got here. And in this particular example, you'll notice that it always takes in the first and last name, but accepts an arbitrary number of keyword arguments as well. So now the definition of build profile expects a first and last name, and then it allows the user to pass in as many name value pairs as they want. And notice now we have a double asterisk before this parameter, and that's simply to create an empty dictionary called user info and pack whatever name value pairs it receives into this dictionary. And within the function, you can access the name value pairs in user info just as you would for any dictionary. So what have we done? We've gone ahead and created an empty dictionary called profile to hold the user's profile. And then we've added our first and last name to this dictionary because we'll always receive these two pieces of information from the user. And then at line 207, we go ahead and loop through the additional key value pairs in the dictionary user info and add each pair to the profile dictionary before finally returning the profile to the function call line. And then we go ahead and call our function with the relevant values. And now let's go ahead and print this out to see what our output would be. And there we are. We can now see we've got our first name Albert, last name Einstein, location Princeton, and field physics. So the returned dictionary contains the user's first and last names as stated, as well as its location and its field of study. And so this function would work no matter how many additional key value pairs you have provided in the function call. And we can mix positional keywords and arbitrary values in many different ways when writing your own functions. So it's useful to know that all these argument types exist because you'll see them often when you start reading other people's code. And it does take practice to learn. But right now, just remember to use the simplest approach that gets the job done. So as you progress, you'll learn to use the most efficient approach each time. And that, guys, brings us to the end of our second section. And I've got 3 more programs for you. So go ahead and pause the video here and then play it again when you're ready, and we'll continue and go through the solutions. Welcome back. Let's now dive into our solutions folder. So in this particular function, we need to accept a list of items that a person wants on a sandwich, and then have one parameter that collects as many items as the function call provides. And then call that function 3 times using different arguments. So let's go ahead and write out our make sandwich. And then let's go ahead and put our asterisk followed by items. We'll then put our document string in place before printing out a statement. And then we'll go for our for loop, so for every item in items. And then let's print out a message, which is adding to your sandwich. And then finally, let's call make sandwich 3 times with 3 different values. And let's go ahead and print this out. Wonderful. And we can now see this is being called 3 times. I'll make you a great sandwich with our toppings, which is roast beef, cheese, and lettuce. We then move to our second one, which has turkey, honey, and jam, before finally moving to our final one, which has mushrooms and cheese. And let's now move over to the second program, where we need to start with a copy of our user profile, and then build a profile of yourself by calling build profile and using your first and last names and 3 other key value pairs that describe you. So I'm going to simply go ahead and go back into my functions here and copy this out and let you practice as you wish. You know how the program now runs. You can go ahead and add more parameters to this. And the best way is to learn by doing. So I'll let you get on with that program. And let's finish off with our final one. So this is where we need to write a function that stores information about a car in a dictionary. And again, we should always receive a manufacturer and a model name. So they will be our first 2 parameters, and then accept an arbitrary number of keyword arguments before calling that function and the required name value pairs, such as the color or an optional feature. And again, our function should work for a call just like this one here. So I'll use this as my example. I'll just put that here. So let's go ahead and jump into this. So again, first I'll go ahead and make my function here, make car, and I'll take my 2 parameters, manufacturer and model, before putting my keyword arguments here, which again, if you remember, will be stored in my dictionary. So I've now labeled that as options. And then I'll go ahead and put my doc string. And then let's start writing out our dictionary. So I'll call this car dict equals open bracket. And let's go ahead and write down our manufacturer and our model. And then let's move on to writing our for loop. So for option and value in options.item, let's go ahead and call our dictionary here. And let's wrap option around this and equal this to our value before going ahead and returning our dictionary. Fantastic. So again, we've got our example that has been given to us in our question here. And I'm going to simply go ahead and print car. And let's go ahead and run this. Oops, and we've got an error here. Traceback error. And that's again on line 266, which is car. And it states attribute error. Dict object has no attribute item. Did you mean items? And again, as you can see, in line 261, our items method is not being highlighted. So let's go ahead and add that S there, and you can now see that color has changed. And once again, let's go ahead and run this. Beautiful. And you can now see we get our output as expected. Manufacturer Subaru, model Outback, color blue, and towback package true. Wonderful. So I hope you're now feeling more confident in completing programs using functions and arbitrary keyword arguments. Let's now jump back into our functions file. We'll now be moving over to storing your functions in modules. So now one advantage of functions is the way that they separate blocks of code from your main program. And now by using descriptive names for your functions, your main program will be much easier to follow. And you can go a step further by simply storing your functions in a separate file called a module, and then importing that module into your main program. So many of you may have worked with import statements before, but for those who haven't, an import statement tells Python to make the code in a module available in a currently running program file. So storing your functions in a separate file simply allows you to hide the details of your program's code and focus on its high-level logic. So knowing how to import functions also allows you to use the libraries of functions that other programmers may have written. So let me go ahead and show you all of the several ways in order to import a module. So now the first thing we need to do is create a module, and that's any file that ends in .py. So let's make a module that contains this function, make pizza. So I'll go ahead and create a new file called pizza, and I'll paste out a program that I had written out for this lesson. And then we'll go ahead and make a separate file called making pizzas. And let's create a new file here, which is named makingpizzas.py. And now within this, we're going to import the module that we've just created and then make two calls to make the pizza. So let's go for import pizza, and let's call our import, which is pizza.make_pizzas, with two variables, which will go for 16 and pepperoni. And then we'll do one more here, and we'll go for 12, and we'll go for mushrooms, green peppers, and extra cheese. So now when Python reads this file, the line import pizza tells Python to open the file pizza.py and copy all the functions from it into this program. And now you don't actually see code being copied between files because Python copies the code behind the scenes as the program runs. All you need to know is that any function defined in pizza will now be available in making pizzas. So now what have we done? We have called this by simply entering the name of the module, which is pizza, followed by the function name. And you can now see that was make pizza here. So let's go ahead and clear our terminal and run this. And we can now see we're getting the same output here, making a 16-inch pizza and then a 12-inch pizza. And so the first approach was simply importing, in which you simply write import followed by the name of the module. And if you use this kind of import statement to import an entire module, each function will be available through the following syntax. So let's go with module name, which in our case was our pizza, followed by our function name, which is our make pizza, and any arguments that you would like to put in this. So let's go ahead and comment this out. But let's say we now want to import specific functions. So now you can also import a specific function from a module. And the general syntax would be from module name, import the function name. And we can do as many functions as you would want from a module by simply separating each function's name with a comma. So we could go with function underscore name 1 and the function underscore 2 and so and so. So the above example would simply look like this. From pizza, import make underscore pizza, and then simply go ahead and call your make underscore pizza. You can see that's now been corrected there above. We can take that out. And make pizza followed by 16 and then pepperoni. And now with this syntax, you don't need to use the dot notation when calling the function. And because we've explicitly imported the function make pizza in the import statement, we can call it by name when we use the function. So what about if you want to use an alias? So that is where we bring in the keyword as. Using as to give a function an alias. And the reasons we do this is in case the name of the function you're importing might conflict with an existing name in your program, or even if your function name is long. So we can use a short, unique alias, which is an alternative name similar to a nickname for that function. So again, let me go ahead and copy this and paste this below here. And then let's separate this. Wonderful. So here we give the function name make pizza an alias, which is MP. And then we can go ahead and replace make pizza as MP here. But then what's happening? It's not really being highlighted in any way. So to do this, we would simply add in our as keyword and write in MP and then replace make pizza with MP here. And now it's just renaming the function make pizza to MP in this program. And anytime we want to call make pizza, we can simply write MP instead. So let's go ahead and do an example one. MP, let's go for 10 and let's go for cheese. And let's print this out. And we can now see we're getting our make, our 16-inch pizza, pepperoni, and then cheese here. So again, if we go for our general syntax, that would be from your module name, import your function name as fn. But now we've used as to give a function an alias. But what if we want to use as to give a module an alias? So now we can go ahead and also provide a module with an alias. And now giving a module a short alias like P for pizza will simply allow you to call the module's functions more quickly. So let's take this as an example. If we go for import pizza as P, this is now much quicker for you to simply go p.make pizza and then add in our arguments. And so now this module pizza is given the alias P in the import statement. But all of the module's functions retain their original names. So calling the functions by writing p.make pizza is not only more concise than writing pizza.make pizza, but it also redirects your attention from the module name and allows you to focus on the descriptive names of this function. And again, if we go for our syntax here, that would simply be your import module name as mn. And that's module name mn. But now let's dive into something particular here. And let's focus on importing all of your functions in a module. So now you can tell Python to import every function in the module by using the asterisk operator. So we could simply go by writing out from pizza, import asterisk. And what this does is this imports every single function within your module. And then again, we can go ahead and call our make pizza here. I'll just change this to chicken so we can see a different result here. And then print this out. And we can now see making a 16-inch pizza with chicken. So the asterisk in the import statement simply tells Python to copy every function from that module pizza into this program file. And because now every function is imported, you can call each function by its name without using that dot notation. And however, it's best not to use this approach when you're working with larger modules that you didn't write. Because if the module has a function name that matches an existing name in your project, you can get unexpected errors. So the best approach is to only import the functions that you want or need for that specific task. And again, to finish off with our syntax here, that would simply be from module underscore name, import asterisk, which is everything. So now you need to keep a few details in mind when you're styling your functions. Number one, not only functions, but all of your code written out should be descriptive. The variables should be descriptive, and these names should have lowercase letters and underscores. And the reason being is that they simply help you and others understand what your code is trying to do. And every function should also have a comment that explains concisely what your function does. And the comment should appear immediately after the function definition and use the docstring format. And that again, if I go into my functions here, you can see I've made sure I do this for every program that we have written. And so now before we wrap up for today, I've got 2 more programs that I want you to do as individual practice. So take this away and go and practice as much as you can in light of functions. If there is anything that you don't quite understand, feel free to comment below and I'll be more than happy to reach out and help. So take a look at the code on the screen now and try to go ahead and work on your printing models function or imports and see how we can simply import the function within your main program and then call the function using any of these approaches. And choose any 3 programs that we've written in today's video and make sure they follow the same guidelines that I've stated out. Amazing. So that brings us to the end of our functions chapter. What a roller coaster of a journey this has been. So now in the first chapter, we learned how to write simple functions and to pass arguments so that your functions can have access to the information they need in order to do their work. You then learned how to use positional and keyword arguments and how to accept an arbitrary number of arguments. And you saw functions that display outputs and return values, working with if statements and while loops. So using functions makes your programs easy to read, and good function names summarize what each part of the program does. So now in chapter 9, you'll learn to write classes. And classes simply combine functions and data into one neat package that can be used in flexible and efficient ways. And now this is around object-oriented programming, which is one of the most effective approaches to writing software that represent real-world things and situations. And you can create objects based on these classes. I can't wait to show you the value of this video. So keep up the great work, and I'll see you in the next one. Thank you.